This is Mastering Mathematics with your teacher, Karen Weston.
Hello, welcome back to Mastering Mathematics. Today, yes, is a brand new day, but you had some homework to do last night. Yes, the adults and my little grade 2 and grade 4 and grade 6 students, you two were given some work. Guess what? Grade 6, grade 2 and grade 4, I'm going to still set you some more work, and then next week we will be correcting all of them before we give you something else. So get your books, get your pens, papers, and let's have you writing these questions. Grade 6, grade 4 students, this is what I want you to be doing. John has 48 marbles. John has 48 marbles. Tom has 3 less than John. Remember those words, less than John. But Jack has 14 more than John. How many marbles do they have all together? I know you're writing, so what I want you to be able to do is to pick out your main parts, okay? So again, the first thing we want to know is that you know John has 48 marbles. Tom has 3 less than John. Write down that information. Tom has 3 less than John. And Jack has 14 more than John. And I want to know, how many marbles do they have all together? Got that? Right. Second question. What is 25% of $9.80? What is 25% of $9.80? And your last question for today, a class has 24 girls and 16 boys. A class has 24 girls and 16 boys. What percentage of the class is boys? What percentage of the class is boys? All right, so our grade 2, our grade 4, and our grade 6, you're on your way. Today, I want to test my grade 2s and to see if they know something about time. Okay, so I'm going to ask them to tell me, how many minutes do we have in 1 hour? How many minutes do we have in 1 hour? Again, general knowledge. How many months are there in 1 year? How many months are there in 1 year? And how many days do we have in 1 week? How many days do we have in 1 week? All right, so grade 2, we want to know, how many minutes do we have in an hour? How many months do we have in a year? how many days are there in 1 week? Last time I asked you to make certain that you knew your 2 times table. Today I want you to add and know that we're going on from our 2 times to our 3 times table. If we start building up from now, even if you didn't know them before, you will see that by the time that exam comes around, as long as we start paying attention, we will know them. Okay? And parents, please encourage them. Make it be fun time because they too need your support. Teachers with the project, please remember, the project is not a class exercise to tell me what a vulgar fraction is, how it is represented, how it looks. I want to know where in the real world would we be using those fractions. You're going to give me an application to show where whatever information you're giving me is being used, not giving me definitions of words for fraction. I know that already. Okay, give me something new. All right, so my big people, you had a lot of time, even if you didn't have the time last night to complete your homework, to say, okay, while Miss Weston chat with those people, let me just hurry up fast and do that problem. Okay, so cheaters, homeworkers, diligent people, let's see what we did. Where did we leave you? Yes, we were right here. CD is parallel, and we know the mere fact it uses the word parallel means that the gradients are the same. Okay, so it says CD is parallel to AB and passes through the origin, and we know that the origin would always have coordinates 0, 0. And our definition, any line parallel to another line, they have the same gradient. And they are asking us to write the equation of the line. Because they started with that particular gradient, with the fact that it passes through the origin, it means that they want us to use the coordinates of the origin to help in our finding the equation of the line. So we would right away be employing what we do know, that the equation of any line, the general form for the equation would have been given as y is equal to, oh, that one is failing us. Y is equal to mx plus c. So we can start y is equal to, yes, the gradient, negative 2x plus c. This line passes through the point 0, which has coordinates 0, 0, implying x is equal to 0, y is equal to 0. So we're going to get 0 is equal to, and anything multiplies by 0, what is the answer? Yes, it is 0. So it would be 0 plus c. So what is c equal to? That is right. So c is equal to 0. Therefore, the equation that we have been asked to find, which is parallel to our y is equal to negative 2x minus 3, would just be equal to y is equal to negative 2x. And that is the answer. All right? So we would have completed that particular part of the question. Then we also have another part. And what is it saying? It says the gradient of a line, we must find that is perpendicular to CD. So they have asked us to find the gradient of a line which is perpendicular to CD. What did we say? The equation of the line CD was equal to CD is equal to negative 2x. Okay, the equation was y is equal to negative 2x. If we have a line perpendicular to that line, what do we know about its gradient? What did we say we have to do? Yes, turn the gradient upside down and change the sign. And we will get what is the gradient of the line that's perpendicular. So watch here. The gradient of this line is negative 2. And we know we can write negative 2 as 2 over 1. Isn't that true? Yes. So what are we going to do to get the gradient of a line that's perpendicular to this one? We are going to turn it upside down. So it's 1 over 2. Change the sign so it becomes a plus. And do we know if we are right? Yes. Because when we multiply a half times negative 2 over 1, what are we going to get for our answer? Negative 1. So we know that that is the correct gradient for a line which is perpendicular to y is equal to negative 2. So we are on our way because the question asked us to calculate the gradient of a line, and that is all. So the gradient of the line which is perpendicular to CD, that gradient is equal to a half. And that's the answer. And that was the question from CXC. All right? By the time we look at this paper, 7 out of 11 points you would have gotten. The next topic that I'm going to be doing with you, which is function and relations, will take care of the first part to this question. And that is why I'm saying we have enough information for you at this particular stage to say, that exam is an exam I will pass, without a doubt, because I have been working. And guess what? They are on YouTube. All right. So you're just going to www.youtube.com/mastering. Even if you put in mastering mathematics, it will come and you will see them. Okay. So there's nothing we are not doing to make certain you will get the answers. Send you on a little break. We will be right back to give you some more information.
Whenever possible, draw a diagram. Even though you may be able to visualize the situation mentally, a hand-drawn diagram will allow you to label the picture, to add auxiliary lines, and to view the situation from different perspectives. If you know the answer to a question is incorrect and you cannot find the mistake, start over on a clean piece of paper. Oftentimes when you try to correct a problem, you continually overlook the mistake. Starting over on a clean piece of paper will let you focus on the question, not on trying to find the error. Always read my problems completely before beginning any calculations. If you glance too quick at the problem, you may misunderstand what really needs to be done to solve the problem.
Right, so everybody had a lovely time refreshing oneself, and now we're back for work. Grade 2 students, you would have done your sum, you would have done that information, because they're going to say, but that's easy, I know that. 7 days in 1 week, 12 months in a year, and 60 minutes in an hour. And you would have been correct. Okay? My grade 4 and grade 6 students, you were asked to do something a little more advanced, okay? And guess what? I'm giving you a whole week to get it, because your mommy probably would be saying, oh, I didn't know Miss Weston was going to do that. I don't have time now to help you. But we're going to talk about it. And I'm going to start with you next week, where you're going to give me the solution to all those that I gave you this week. Discuss it with your friends, see if you saw it on the TV. Next time you see me in your school, I know you have my telephone number. You can call me if you can't wait so long, and I will answer you. All right? Now, for my fifth formers, because we have something to prove that we can do mathematics and that we can learn information, and once we have them, that we know what to do. And CXC is not going to fail you, because if you look on the diagram that I have on the board here, you're going to say, but Miss Weston didn't change her diagram from what she had yesterday. And you would nearly be right. But yes, I did change it. It's a new one. Okay? And this is what I'm saying. It's gradient. What can they ask me? That is what you tell yourself when you question yourself every time. Find the gradient. Find a line that's perpendicular to another line. Find a line that's parallel to the other line. Find the equation of the straight line and see what passes through the different points. Every question, every time. Okay? Time permitting, I remember to tell you how you find the midpoint of a given line. Alright? So, we're going to know everything about our lines, and we're going to get that question perfect marks. Hear what this one is saying. The first thing it says, and this again is from the 60 examination paper. It says, in the diagram not drawn to scale, AB is the straight line joining A, -1, 9, and B, the coordinates would be 3, 1. And we are asked to calculate the gradient of the line AB. Okay, calculate the gradient of the line AB. And we can say with a level of confidence that the gradient would have been equal to, and we are not even writing up the formula. We're going to say our y1 would have been 9 and it's -1, and it's over our x1, which would be -1 and it's -3. So we're going to get that it is 8 -4 over -4. So that the answer again would be equal to -2. And that's it, finished. Gradient, okay? -2. Says, write the equation of the line AB. And we know right away we're going using y is equal to mx plus c. We have the gradient and it's equal to -2x plus c. And we're using our smallest coefficients. So we're going to be saying, so we have y is equal to that. Then using b, at the coordinates b, 3, 1. We're substituting 1 for the value of y and 3 for x. So you would have 1 is equal to -2 times 3 plus c. Remember, we're using any one of the coordinates because they lie on the straight line. And we chose it by saying we're using our smallest numbers. So we would have gotten 1 is equal to -6 plus c. So that c then would be equal to 1, bringing over the 6 plus 6. So we can say 7 equal to c, which is equal to the same thing as saying c is equal to 7. And so we come back and the equation would be y is equal to -2x plus 7. That's our equation. All right? It says, write the coordinates of G, the point of intersection of AB and the y-axis. Write the coordinates of G, the point of intersection of AB and the y-axis. And this is where G is. Okay? They would have been giving you that on the paper and you'd see it on your exam paper. Now, here on the paper we would see they're going 2, 4, 6. So midway between would have to be 7. Isn't that true? Yes. And what axis is it on? The y. What do we know? Anywhere along the y-axis, the value of x is equal to 0. That is right. Anywhere along the y-axis, the value of x is equal to 0. So that For our coordinates, we just have to write it is 0. And where is it cut in the y-axis? Yes, at 7. And that's what it is. This is how easy we're getting marks. All right? That is how easy we're getting marks. So the coordinates of G would be 0, 7. Okay? It says, write the equation of the line through O, the origin that is perpendicular to AB. Remember that we did our equation, the line of AB, which was equal to y is equal to negative 2x plus 7. What did we say before? If we want to find the gradient of any line perpendicular to a given line, we just have to turn the equations upside down and change the sign. Okay? And when we multiply the two gradients, the product must be equal to negative 1. And because we did a problem with negative 2 already, where we showed that it could have been written like that, turning it upside down would give us 1 over 2. Changing the sign would give us a positive gradient. So any line perpendicular to AB, the gradient would have been equal to a half x, and we know it passes through the origin, and the equation of the coordinates of the point passing through the origin would have been equal to 0, 0. And when we did that before, what did we see? The value of C would also be 0. So that the equation is just equal to y is equal to a half x. And then it says, write the equation of the line through 0 that is parallel to AB. Write the equation of the line through 0 which is parallel. So this is AB, okay? And any line, so I can take off this now to show you, any line parallel to another line, what do we know? Yes, the gradients are the same. So the equation of that line is y is equal to negative 2x, and by now we know, because it passes through the origin, the value of C is equal to 0. Why is the value of C equal to 0? Because it's not cut in the y-axis. It does not cut the y-axis in any place. So that is why the value of C is equal to 0. Passing through the origin, it's coming right through here. All right? Not cutting at anything. But this time, it would not have been coming up because we have a negative gradient, so it would have been going down. Don't forget that you can have an idea of where it is going because of the sign and what the gradient, if it's negative or if it's positive. So the equation of the line that's parallel to AB and passes through the origin is just y is equal to negative 2x. Is there any sweat? And guess what? You would have gotten 7 marks just for writing. Just for writing. Every time they say something, you're just writing it. You don't even have to say any big calculation for this one because you know your information. Okay? So that is one topic we can say we have under our belts. All right? So that next week, we're going to be working on functions and relations. Okay? So guess what you have done so far? And if I haven't done that, I'll check and see that you do know how to find the midpoint of a straight line, because that too is easy. You want to hear what it is? We're just adding the coordinates of the x's, divide by 2, add the coordinates for the y's, divide by 2, and that's how we get the coordinates. All right? So just getting the sum and adding them, okay? Getting the sum and dividing by 2 every time. So just taking half of the sum of the coordinates of 2 points, and that's the coordinate for the midpoint. We will just make certain that all the summary is in order and that you have your right set of information, because you're ready now to answer any question in terms of grading, straight lines, coordinate, vectors, and we're going to be taking you just now into the geometry too, because you are just ready for this, okay? So next week though, before we take you into geometry, we'll be giving you functions and relations, and grade 6, grade 2, and grade 4 students, and grade 3 and grade 5, you're not omitted too, you know. Please continue to support Mastering Mathematics and to make certain that our students enjoy the topic. I know they are, because I can see it on their faces. Remember, all those who are suffering, all those who have cancer, and any other form of disease which may be ailing them at this moment. Again, remember our own education minister and continue to pray for her. She is always willing and glad when she gets news out of Antigua, and to know that we are holding the fort. So see you next week when we'll be back with another program of Mastering Mathematics.
Join us next time for another in the series, Mastering Mathematics, a production of the Education Broadcasting Unit in the Ministry of Education and ABS TV.